you mentioned, this webinar is organized as part of the Odyssey project, which aims to track energy efficiency progress in Europe. The project is funded by the European Commission through the LIFE program. It comprises two databases, Odyssey for data and indicators, and MUR for policies and measures. And these databases are supplied by contributions from a network of 40 national partners. This webinar relies mainly on Odyssey database and facilities, which provides data up to 2023. Some are still early estimates computed by Enerdata. You can find much more information about data analysis, facilities, etc. on our website. So today, first, I will present the trends in final energy consumption in the EU. Bruno will analyze energy efficiency trends. I will then analyze driver of final energy consumption changes. And finally, I will present you total energy supply trends. So let's begin with the final energy consumption and GDP in the EU. You can see on the charts the final energy consumption in dark blue, total electricity consumption in light blue, and GDP in green. Overall, we see that final energy consumption has been slightly decreasing since 2010. And in fact, there is several periods. So first, between 2010 and 2014, you have a reduction, then an increase between 2014 2019, a sharp reduction in 2020 due to COVID, so final consumption decreased by 5% in 2020. We have a rebound in 2021, and then 2 other years of crisis. In 2022, final consumption decreased by almost 3% due to price rises, and notably energy price rises. And in 2023, due to slower economic growth, final consumption decreased by more than 3%, of a further 3%. So you can see the stagnation of GDP in green in the first chart. So there is a stronger reduction after 2021, almost 3% per year, compared to almost a stagnation before 2021, with a limited reduction of 0.2% per year during this period. You have a similar trend for electricity over the period. So it's interesting to focus on energy prices variations, as we noted that it caused really a sharp reduction in final consumption. In the box plot chart, we can see that the highest variation occurred in industry prices. They increased by more than 50% in 2022 at EU level, and this occurred after already a 15% rise in 2021. So the box plot shows that industry prices rose by between 25 and 85%, depending on the country, which is huge. Prices for households rose by 24% at EU level and by between 5 to 60%, depending on the country. And in transport, the increase in motor fuel prices were more limited in 2022, only almost 20%, but it occurred after a 15% growth in 2021. So overall, over the 2 years, it's almost a 30% increase. We can see on the graph at the right the average price for final consumers, which is computed as a weighted average price for all end-use sectors that I mentioned. And this average price increased by 36% at EU level in 2022. So it explained why the final consumption has such a decrease in 2022. We can analyze the variation in final consumption by sector. So we see that over 2010-2021, total final consumption remained almost stable. The interesting period is since 2021, and we see that the sharp decrease is driven by industry, who has seen a 6% per year decrease in its consumption, which is directly linked to price rises that I just showed you. We also observe an acceleration of the decreasing trend seen previously for buildings, so both households and services. And final consumption in transport sector increased since 2021, despite higher motor fuel prices. We observe similar trends for electricity, which are not represented on this slide. The only difference is the reduction for services, which was twice lower than in electricity than in the total final consumption. So this EU trend can be observed in most EU countries, as final consumption decreased in 22 EU member states since 2021, with a steep reduction above 3% per year in 11 countries, as well as at EU level. So now I will let the floor to Bruno for the energy efficiency trends.
Thank you. Good morning, everybody. Next slide, please. So I will discuss how energy efficiency is changing in EU countries and how we measure energy efficiency progress in Odyssey. This is done with indicators in physical units of specific consumption with different units selected to be as close as possible to energy efficiency. We have about 300 energy indicators, so I'm not going to present all of them. You have example here for the different sector, just to show the different units that are used, and this is very important to always select the best unit. And to have alternative units depending on the information available. Now, I will not show you the 300 indicators. I will focus on two sectors which are important: space heating, that's the next slide, and transport. With respect to space heating, which is the dominant end use for household, which represents 64% of the consumption in 2023, energy efficiency is monitored for new dwelling and for the dwelling stock, and the unit we use is kilowatt per square meter to have some kind of technical indicators. For new dwelling, energy efficiency is driven by energy efficiency standards. For existing dwellings, the main driver is renovation and the change in heating appliances. The renovation is strongly linked to policy support, which depend on the country and is fluctuating over time depending on the policies and different factors. The impact depends on the number of renovation, the level of renovation, and the quality of the renovation, and also of possible rebound effects that may limit the full impact of the renovation that was expected ex ante. For heating appliance, the trend is more regular because there is the need to renew the appliance, but it can be accelerated by policy measure. Now, The trend is much affected by the large development of very efficient systems, mainly heat pumps, which can divide the consumption by 3 to 4 compared to a conventional system, and condensing boiler for countries that depend on gas and that still do not have a full deployment of condensing boiler. The change in existing dwellings is probably the most important driver of the average specific consumption for heating, given the fact that there is a low share of new construction. So it means the impact of new dwellings, of the fact they are more insulated, is very limited because they represent now less than 1% of the total stock of dwellings. The specific consumption for heating consumption per square meters has significantly accelerated since 2019, as this is shown on this graph, which only shows 10 largest consumers for heating. And this is, of course, the reflect of the strong price increase in 2022, but also of a sustained effort in energy efficiency. It can be seen that over the period 2014-19, although it was a period of stronger economic growth, the impact was more limited in terms of decrease in unit consumption. And this decrease of unit consumption is the indicator we use for energy efficiency. The next slide shows you what we can say about the renovation of existing dwellings. This is the key question, very important to understand what is going on, but it's difficult to get data on renovation works. It's easier to get data on the diffusion of efficient new appliances. We are collecting different indicators with different success. So it means the number of countries is not always very significant because such data are not available on a yearly basis. We use three indicators here, the annual number of renovation. We have 3 countries that monitor that regularly and for which we have data in Odyssey, and we can see that there has been an acceleration of the number of renovations since 2020. So in the recent years, that is correlated to the period where the specific consumption has decreased significantly. I did not show data on Italy, but they have also very good monitoring, but it's in terms of energy saving, not in number of renovation, which shows that the data are not always consistent, but there is an intensification in the recent years. In terms of dwelling equipped with heat pumps, we see also that there is a greater diffusion of heat pumps since 2019. Such data are available in Odyssey and have been updated to 2023 with data from the European Heat Pump Associations, which also published data for more countries than this one. But I took the country where the number of heat pumps is the more important. Sweden has a lower diffusion, but is a country with greater equipment. And another indicator that can be interesting is to see how the share of poorly insulated dwellings have decreased since 2019. Now let's shift to cars, for which represent about half of the consumption of the transport sector. So it's interesting to look at this type of vehicle. In Odyssey, like for dwellings, we monitor efficiency for new car and for the average of the car fleet. For new cars, we use specific consumption, which are corresponding to test values, which are in liter per 100 kilometer for thermal vehicles, gasoline or diesel, or gram oil equivalent per kilometer for electric cars. And for the average of new car now, we use gram oil equivalent per kilometer. For the car stock, we can use different indicators. 2 more popular we are using is gram oil equivalent per kilometer. to capture the technical efficiency and the gram oil equivalent per passenger kilometer to measure the overall efficiency, because at the end, what is needed is to move passenger kilometer. So compared to the previous one, the overall efficiency includes the effect of change in load factor. We use this indicator rather than the technical efficiency so far because it was the indicators proposed by the EU Commission to monitor energy efficiency for cars. Now, what are the trends? First, for new cars, what we can see is that for the recent periods in 2019, there has been really an acceleration in the decrease in the specific consumption of new cars. There has been a tripling in the rate of reduction of the specific consumption at EU level, and this is linked to the rapid penetration of electric and hybrid cars, which their market share increased from 3% in 2019 to 21% in 2023. And as they are more efficient than thermal cars, this explains this big difference. And the countries which show the largest decrease, like Sweden, Finland, are countries where the diffusion of such cars are more important. Now, we can see great progress for new cars. What happened with the stock of cars, which is the next slide. As I said, we have two indicators, the technical efficiency in QOE per kilometer. This is in the upper graph shown in orange. And we can see that since 2013, the improvement has been quite limited, only 0.2% per year. And if we look at the overall efficiency, which is a QOE per kilometer, it has stopped improving in 2013. It was decreasing before from 2000 to 2030 by around 0.5% per year. But since 2013, and especially since 2019, it has been increasing. This deterioration of energy efficiency is the result of a significant decrease in the occupancy rate that is shown in light blue, which was significant in 2020, but now even in 2021-22, the occupancy rate was not back to its pre-COVID level. Now, the graphic on the bottom of the slide tried to explain, to understand why with such a great improvement with the technical efficiency of new cars, we see a limited impact on the average of the car fleet. So we tried to simulate how the specific consumption of new car in QE per kilometer would have changed with taking into account the fact that the new cars are more efficient. So this simulation is showed in light blue, and the gap between the actual value in orange and the blue value show the effect of the real driving condition versus the test values, because I remind you the values for new car correspond to test value. Although the tests have been improved, this is why most of the data started in 2013, which correspond to the change of standards, which are supposed to be closer to the real condition of driving, but still the type of driving, the fact that plug-in electric hybrid cars are not used as they are supposed to be compared to the test, have an implication on this gap. Then I will stop with the example by sector and now by end use or subsector and shift to how we measure overall energy efficiency, because we have so many indicators that it would be boring and it's difficult to get what are the trends at a sector level. This is why we developed what we call the energy efficiency index, called ODEX, which is measured from the variation of the specific consumption by end use or subsector. See the example for cars and space heating. And as we are mixing different units, we use index of variation. And for each end use of subsector, the average index is weighted with the share of each end use in the sector consumption to get an index by sector. ODEX is calculated presently based on about 30 end-use subsector or transport mode, and you can have a look at on the website. There is a methodological document explaining how ODEX is calculated. So the trend in the ODEX is shown in the next slide. In black, in the middle, you have the average for all sectors, and the different sectors are shown in different color. What we can see is that the energy efficiency of final consumers, all the sectors shown here, has improved on average by 1.7% per year since 2019 in the EU. This represents a net acceleration compared to the trend before 2019, which was only 1% per year. The largest improvements are for household over the full period, and it has been rather regular. And this is followed by industry, which on average since 2000 has improved by 1.3% per year, with a large improvement in the past, before the financial crisis, and in recent years. Transport and service are lagging behind, with progress of about 0.7% per year over the period. And for transport, the problem is coming from cars. As we have seen, there is very little improvement. The recent intensification of energy efficiency progress may be partly linked to higher energy price, and this is something that we are trying to better correct, better take into account in the calculation of this energy efficiency index. So now, this turn to Estelle to continue with the presentation.
Yes, thank you, Bruno. So I will present you drivers of final energy consumption changes. And first, we will focus on one of the main driver, which is energy savings. So these savings are directly derived from the ODEX that Bruno just showed you. So first, let's focus on the left-hand chart. We can see on it that in 2023, energy savings of final consumers reached 250 megato in the EU, which means that without these savings, final consumption would have been almost 30% higher. I think we clearly seen three periods. Annual additional savings have increased significantly since 2020 by almost 17 megato per year, which is well above the average registered over 2000 and 2014, which was around 10 megato per year, and 3 times higher than savings measured over 2015-2019. And we really see these three periods on the chart. Now let's look at the two pie charts. They are meant to compare the shares of each sector in both energy savings and final consumption. And in fact, you can see that industry and households accounted for 77% of the savings, while only representing almost just more than 50% of final consumption. On the other end, transport and services lag behind, with a share of savings twice lower than their shares in final consumption. Thanks to these savings, EU households have saved in 2023 540 euros in their dwellings, plus 150 euros with their cars, with the motor fuel expenses. Now, I hope that you like waterfall charts and decomposition, because we will go through several of them. So first, the decomposition of final energy consumption between 2021 and 2023. Over this period, final energy consumption decreased by 70 megaton. The activity effect contributed to increase final consumption by 26 megaton, with in this activity effect, 35% is due to transport and 30% due to services. Thankfully, energy savings more than offset this activity effect by reducing consumption by almost 50 megaton. As we have seen, households and industry are the main contributors to these savings. It is interesting to note that climatic variations largely contributed to the reduction, cutting consumption by almost 20 megaton, which represent a quarter of the total reduction in final consumption. And finally, structural changes towards less energy-intensive branches in industry, or towards more efficient mode in transport, or towards services instead of industry in the repartition of the GDP, further reduced consumption by 16 megaton, of which 85% of this effect comes from industry. If we look at the previous period, so between 2010 and 2021, final energy consumption decreased by 43 megaton. So I think you can note that it's 11 years and the reduction is quite lower than during this 3 years period, 2021-2023, where the reduction was 70 megaton. So if we come back to 2010-2021, the economic and demographic growth, the increase in traffic and in number of household appliances, etc., which constitute the activity effect, contributed to increase final consumption by 80 MTO. The energy savings more than offset this activity effect and reduced consumption by almost 100 megaton. And the climatic variations between these 2 years were significant and reduced consumption by a further 26 megaton. If we look at what this final consumption variations translate in CO2 emissions, we obtained this chart. It's new. It's a new tool that we developed in the December project. So you can go to this CO2 decomposition tool to check the decomposition by sector. Here you have the decomposition of the total CO2 emissions from final energy consumption. So this emission decreased by 262 megaton of CO2 between 2010 and 2022. The activity effect contributed to increase CO2 emissions by almost 118 megaton of CO2, with 30% coming from both industry and transport. Energy savings and decarbonation of the energy mix offset these activity effects twice over by reducing CO2 emission by almost 200 and more than 150 megaton CO2 respectively. And climatic variations also contributed to the reduction, cutting CO2 emission by 56 megaton of CO2. So now we are going to look to the total energy supply trends with another decomposition chart. So we will focus on the recent years. Between 2021 and 2023, total energy supply decreased twice faster than final consumption, being decreased by 140 megaton, when, if you remember, the decrease in final consumption was 70 megaton. So it's really the double. A quarter of the total supply decrease is explained by changes in the power mix, with a higher share of renewable. They have increased by 8 points between 2021 and 2023, and lower shares of thermal generation and nuclear power plant in the power mix. And overall, this change in the power mix reduced total supply by 32 megaton. Non-energy uses also contributed significantly to this decrease by 20 megaton, with a drop in petrochemical production linked to high gas prices. So finally, it's interesting to compare this savings, both the final consumption savings and the savings from the power sector, to the total energy supply. So we see that this total energy savings contributed to 428 megaton in 2023, with almost 60% from final user and 40% from the power sector. And in fact, they represent the first fuel just ahead of oil, which means that without these savings, we would have had 430 megaton of consumption the consumption would have been higher, and that's why we call the energy savings the first fuel, because they represent a consumption that didn't occur. If we added up the savings since 1990 instead of 2000 like it is on the chart, energy efficiency would be by far the first fuel. So now I will let Bruno conclude.
So what we have seen is that the rate of energy efficiency improvement has clearly accelerated since 2019. And going back to the title of the session, the various crises that describe Estelle at the beginning did not play a negative role. Mainly because there has been an intensification of policy measure with the various reinforcement of the directives on building, energy efficiency, and national measures also, especially on renovation. And this has been also reinforced by the higher prices during this period. And this was particularly true in industry and for household. Transport gives mitigated results, as we have seen, poor saving for cars, which are not in line with what we see with new cars, but we can expect that the diffusion of electric vehicles, even if it is slowing down very recently, should be seen in the extension of the efficiency for cars, for the car stock. Both for cars and heating, behaviors play an increasing role. It was negative for cars. It means they did not decrease the consumption, but positive for household in the sense that it contributed to the decrease of consumption. For them, for household, part of this behavioral change may be due to the higher energy prices and maybe partly reversible. This will be a topic on which we will try to make more analysis in the future in the framework of the project. Since 2021, energy saving contributed mostly to the rapid decrease in consumption, but as was shown on the graph by Estelle, behaviors, and she did not mention it, but the others corresponded to behaviors, especially in the household sector, structural changes, and also climate had a significant impact. Primary consumption has decreased much faster than final consumption. Since 2021, it is even twice faster. And this is mainly linked to the higher contribution of wind and solar in the power mix and also the phase out of nuclear in some country. This decoupling will continue in the future with the growing share of renewables in power generation. That's all for our conclusion, and we are ready to answer to your question. Thank you for your attention.